All right, welcome back here to part two. In this part, we're going to look at a couple examples of using the triangle sum theorem, some pretty easy ones here. Also talk about a slightly different variation about solving number two here as well. So in this triangle, pretty easy to see. We know two of the angles, and we're going to need to find the measure of the third. This is going to happen a lot. We're going to find triangles all over the place, and we're going to need to find the measure of one of those angles. A lot of different ways we could go about it. We could set up an equation, right? We could use the theorem to set up an equation, something like x plus 96 plus 21 equals 180, right? So you could set it up like that and solve for x. Some people don't like that, especially with one as simple as this. So it's okay if you don't do it that way. Another thing you could do is you could take 180 and you could subtract away what these two angles add up to be. So 96 plus 21. So in that case, you know, a little bit of a simpler, it's more of a calculation thing, but it's the same thing that sort of takes place in the equation form as well. So, you know, let's finish this off and find the measurement of x. This comes out to be 117. So then I need to do 180 minus 117. And so that leaves x to be 63. X is going to be equal to 63. 63 degrees. We're talking about the measurement of an angle. Again, a couple different ways to go about it. Perhaps if we had some variable expressions rather than specific angle measurements, we may want to set up an equation. But since we're dealing with specific measurements, it's probably easier to go. It's probably a little bit easier to go with this one right here. Anyway. Hopefully for those of you that are at home, those bells are really bringing back memories for you. Anyway, question number two here. We're going to find the value of x in this particular diagram, and a couple different ways of doing this. One of them is making use of a particular theorem that we learned last semester called the exterior angle theorem. And so I'll just briefly state this. So the exterior angle, which is this angle that's on the outside, created by one of the sides extending out, right? So this 100 degree angle is an exterior angle. The theorem says that the measure of this angle is equal to the sum of the non-adjacent or remote interior angles. So not this one, because this one is adjacent to it, but the sum of these two angles. So that equation would look something like this. I promise I was not being edited out because I was cursing there, just the bells. Anyway, 100 is equal to 2x plus 3 plus 51, right? So that's our equation using the exterior angle theorem, and we could solve it that way. It's totally fine, works great in this situation, and is pretty much equivalent to the other equation that I'm going to write, but I'll go ahead and go with this. The other way we can do this is we always know that exterior angles like this one are always forming a linear pair with an interior angle. So we can use that to know that this angle would have to be 80 degrees, right? The reason again for that is because these form a linear pair and thus have to be supplementary. Anyway, if we do it this way, we could use the triangle sum theorem to solve this. You can kind of go either way. I'll write out this equation as well. So we'll add these angles together, 80 plus 51 plus 2x plus 3, and all together those need to equal 180. Turns out these equations are actually pretty much identical, because if I take away this 80, right, from both sides, what do I end up with? I end up with basically the equation that we just wrote down using the exterior angle theorem, right? 100, the exterior angle, equals these two angles added together. So they're basically the same equation, but you can go about it however you'd like. Anyway, let's go ahead and finish this one off. I'll go ahead and finish solving this. Subtract 54 on both sides. And I get 2x equals 46. And then I can divide by 2, and we'll figure out that x is equal to 23. And there we go. Well done. Anyway, catch you again in part 3.